Okay, so everybody look at the key concepts box on page 491. Remember, even though they put them usually after example 1, I like to look at them first because that's going to help you with example 1. So we have some new vocab words. Now you may have heard prime numbers before, but you may not have heard composite, or maybe you did. But what is a prime number? Colin.
A whole number with exactly two distinct factors, one and itself.
Good. So prime numbers are those numbers where you can only multiply 1 times itself. Those are prime numbers. There's only 2 factors. 1 and that number. Examples are 2, 3, 7, and 11. Look back at your independent practice from yesterday, which I forgot to staple your paper. I know that. I will come around later. Look back at your independent practice. Look at just page 487. We see 2 prime numbers on page 87, only 2. What are those 2 prime numbers? That means they only have a factor of 1 and the number itself. Colin, tell me 1.
1 and 59.
So is 1 and 59 the prime number? What's the prime number? A prime number is a whole number, one whole number, with exactly 2 distinct factors, 1 in itself. So what is that number? That one number that only has a factor of 1 in itself? 59. Numbers on number 8, you had to find the factors of 59. There were only 2, 1 and 59. That is a prime number. There's another prime number on page 487. What is it? It only has a factor of 1 and itself. Zari?
Number 14. 1 times 37.
But just like I told Colin, so were you listening when I was talking to Colin? The prime number, good. The prime number is not 1 and 37. The prime number is 37. The factors of 37 are 1 and 37. Focus. So 37 is also a prime number because there's only 2 factors, 1 and 37. Some other examples. Can't remember if I said this. 2, because you can only multiply 1 times 2. 3, because you can only multiply 1 times 3. 7, because you can only multiply 1 times 7. And 11, because you can only multiply 1 times 7. Remember, prime numbers, we're worried about factors, not multiples. So you may be saying, but I can multiply 2 times 4 and get 8. Well, that has nothing to do with being a prime number. Because prime numbers is just worried about the factors. What are the factors of 2? Well, only 1 and 2. What are the factors of 11? Well, only 1 and 11. Now, prime numbers have 2 factors. 2 factors only. That's it. No more, no less. Composite numbers are what? Zari.
Composite number. A whole number with more than 2 factors.
Good. So a composite number just means there are 3 or more. There's not exactly 3. There could be 158 factors. It just means that there are 3 or more. So composite numbers are numbers where 1 is a factor, the number itself is a factor, but there's also other factors. Numbers like 4. 4 has a factor of 1, 2, and 4. So there's 3 factors because 1 times 4 equals 4 and 2 times 2 equals 4. 6 has factors of 1 and 6 and 2 and 3. 1 and 6 and 2 and 3. So 6 has 4 factors. 10 has 4 factors. 1, 10, 2, and 5. 20 has, I think, 6 factors, 1 and 20, 2 and 10, 4 and 5. Because 1 times 20, 2 times 10, and 4 times 5 all equal 20. So does everybody understand the difference between prime numbers and composite numbers? How many factors do prime numbers have? Aaron.
1 and itself.
How many factors does a prime number have? Smith.
2.
2. Listen to the question. How many factors does not mean what are the factors of a prime number? Do you hear the difference in the question? How many factors do prime numbers have means I'm just looking for one number. Prime numbers have 2 factors. If I said what are the factors in a prime number, then Aaron, 1 and itself would be the answer. Listen to the question so that you know exactly what I'm asking for. Composite numbers have how many factors? Zadie.
They have more than 2 factors.
More than 2, so 3 or more. As long as it's 3 or more factors, then it's a composite number. Now, we have some numbers that are neither prime or composite. 1 has only 1 factor. How many factors do prime numbers have to have, class? 2. How many factors do composite numbers have to have?
3 or more.
3 or more. If 1 only has 1 factor, does it go with either of those? So it is neither prime nor composite. Another number that is neither prime nor composite is 0. Because how many factors does 0 have? Mason? Has more than that. Aaron?
1.
Has more than that. Lena?
All the numbers.
An infinite amount of, because you can multiply anything to get 0, as long as you multiply it by what?
0.
0. So, 0 has a never-ending number of factors. But also, so star it, this is important, 0 is not a whole number. So that's another reason why it's neither prime nor composite, because it's not a whole number. And look, prime number, a whole number. Composite number, a whole number. 1 is a whole number, but 0 is not, because is it an amount at all? If you have 0 of something, do you have some of that thing? If you have 0 pieces of candy, do you have any candy?
No.
No. If you have 1 piece of candy, do you have a whole piece of candy, at least? Colin?
Yes.
Yes. So, there's 2 reasons. First of all, 0 has a never-ending number of factors, but most importantly, 0 is not a whole number. So it is neither prime nor composite. Okay, I'm going to give you a handy anchor chart that has all of these rules in, I think, language that's a little easier to understand. So, it's printed in color too, because our new printer has color. So I'm going to hand this out. You can keep it to the side. That way you can refer back to here instead of having to flip pages back and forth. Okay, I'm going to go ahead. Actually, I'm going to have helper number 3 pass these out. Okay, so now that you have your handy chart, your handy anchor chart, you don't have to flip back and forth. You can look here to figure out, is a number prime or composite? Now, yesterday, we did a whole lesson on finding factors. That's going to help you, because if you can find the factors, then you know, does it have 2 factors and it's prime? Or does it have 3 or more factors and the number is composite? So, everybody, finger or pencil on example 1 on page 491. Okay, please read in your head while I read out loud. Blair is arranging 18 cupcakes on a shelf. So I'm imagining Blair probably works at a bakery. She's got a shelf. probably in like a case at this bakery, and she has 18 of these chocolate cupcakes. I think that's chocolate. Yes. And she wants to arrange them. She needs to arrange them so that people can see them, so that they want to buy them. Okay. Find the factors of 18. Use arrays to find the factors. So finding the factors of 18 is going to tell us, okay, this many rows, this many columns. Okay? Or this many rows, this many columns. She wants to arrange it so it can fit. So she needs to figure out all the different ways she can arrange them to figure out which one fits the best. So, first of all, we know no matter what the number is, we can always put it in one row with that many cupcakes in it. So we can put it in one row of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. With one row. We know that. We know for every single number, we can put it in at least one row. The columns is whatever that number is. Because if I multiply 1 times 18, I get 18 cupcakes. Now another way. Let's look at the digit in the ones place. The digit in the ones place is 8. Is 8 even or odd, class?
Even.
Even, because you can multiply 2 times 4 to get that number. If the digit is if the digit in the ones place is even, then the whole number is even. All even numbers can be divided by 2. Every single even number can be divided by 2. Now, it's a basic fact. 2 times what equals 18? Class? 9. So, we can have 2 rows with 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. And we still have 18 cupcakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 2 more factors of 18. Next, we know our basic facts. All the factors of 18 are basic facts. Well, except for 18. 18 is not a basic fact because it's larger than 12. But all the rest of them are. Also, we just know, okay, what comes after 2, class? 3. So we're going to test it. We don't need to divide to test it because it's a basic fact. 3 times what equals 18, class?
6.
6.
So another way we can arrange it. 1, 2, 3 rows. 1, 2, 3, 4, 5, 6 columns. And we still have 18 cupcakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We can also do the opposite. 6 rows, 3 columns, 9 rows, 2 columns, 18 rows, 1 column. But do we have to list those factors a second time? Carla, sit up. Do we have to list those factors a second time? Do we need to say that, well, 1 and 18 are factors, but also 18 and 1 are factors? Because those numbers are the same. So now we know, in order, the factors of 18 are 1, in order from least to greatest, 2, 3, 6, 9, and 18. Now, Michaela did something really good on her homework, on her independent practice, that proved that she knew that a certain number was not a multiple of another. So what she did was, we'll do that on this. She basically said that 4 could not be a factor of 18 because 3 times 6 equals 18. Wait, no, sorry, like this. Because she said 4 times 4 times 4 equals, oh my gosh, I'm just having brain fart after brain fart. 4 times 4 equals 16, and 4 times 5 equals 20. 18 comes between 16 and 20. So because 4 times 4 is 16 and 4 times 5 is 20, there's nothing we can multiply 4 by to get 18. We also know 5 is not a factor because 5 has to have what in the ones place? Aaron? A 0 or a 5. 8 is neither of those things. And now we've met in the middle. Next is 6. We already know it's a factor. So remember, once you meet in the middle, so you basically want to try all the numbers between 3 and 6 to see are they also factors. But we know they're not. So 18 has more than 2 factors. So it is what type of number, class? Prime or composite? Without looking, it has more than 2 factors. So it is what, class?
Composite.
Composite. There we go. Okay, any questions about example 1? Now that's using arrays. Arrays take a long time. We don't need to use arrays every time. We can use basic facts and then simple multiplication or division. Whichever one you're better at, you can do. You just have to test. So if you're better at multiplication, use multiplication, and I'll show you how in just a minute. Oops. Helper number 1. Hey, everybody, finger a pencil on example 2. Okay, read in your head while I read out loud. Sarah is at the park. Okay, I'm imagining her at Lake Shelby Farms. She counts 73 kites. I'm imagining a really large number of kites in the sky. I'm not going to count 73 in my brain, but I know 73 is a pretty big number. Carla, sit up. Get your arms off your desk. I'm not going to tell you again. Scoot your chair in. I'm not going to count all 73 in my head, but I'm going to imagine there's a pretty big number. Write the factors of 73. Okay, that means I need to find the factors of 73. Tell whether it is prime, composite, or neither. Okay. The factors of 73 are blank and blank. Well, we automatically know the first factor of 73 is what, class? 1. Which means the factor pair for 1 is what, class? 1 and
73.
73. Is 73 a multiple of 2? How do you know? How do you know that 73 is not a multiple of 2? Zari.
Because 2 is even and 3 is odd.
Well, it's not because 2 is even. But it's because of that second thing you said. The digit in the ones place is odd. It's not because 2 is even. That has nothing to do with it. But the digit in the ones place is odd. But I don't want you guys to tell me, hey, the 3 is odd. I want you to tell me 73 is odd. Because this is not the number 3. This is the digit 3 in the number 73. So, 73 is odd. Can 2 be a factor of an odd number? No, it can't. So we know not 2. Let's test 3. Because is there a basic fact with 3? That can get you, what's 3 times 12? Sorry, that's what I should have asked. 3 times 12 is what? Cullen?
36.
36. 73 is greater. So we don't have a basic fact that tells us if it's 3. So we're going to come to the side, and we're going to do that easy division. 3 goes into 7 twice. 2 times 3 is 6. 7 minus 6 is 1. If you're comfortable, work ahead of me, but only on 73 divided by 3. Okay? Don't try another one. Bring down the 3. 3 goes into 13. 4 times. 4 times 3 is 12. 13 minus 12 is 1. Is 3 a factor of 73? Nope. So let's try 4. What's 4 times 12? Just shout it out. What's 4 times 12?
48.
48. Uh-oh, 73 is bigger, so let me test. Work ahead of me on 4 times 73 if you can. 4 goes into 7 once. 1 times 4 is 4. 7 minus 4 is 3. 4 goes into 33 8 times. 8 times 4 is 32. Is 4 a factor of 73?
No.
Nope. Let's think of 5. Is 5 a factor of 73? How do we know?
No.
Carla.
Because the only two digits that will be in the ones will be 0 and 5.
And 3 is neither of those things, so we don't even have to test 5. What about 6? What's 6 times 12? Shout it out.
72.
72. 72 is really close to 73. Is it at least 6 apart? So is 6 a factor of 73? No way, because we only get 1 less when we multiply it by 12. Now we're into the basic facts. So we just need to try 7. Can we multiply 7 times anything to get 73?
No.
No. So now we're in basic facts. We know we can't, what is 7, sorry. Yeah. So we're in basic facts. What about 8? Can we multiply 8 by anything to get 73?
No.
Nope. What about 9?
No.
10?
No.
11?
No.
12?
No.
That's all we need to do. Because if anything greater was multiplied by something to get 73, we would have found it when we did 2, 3, or 4, or 5, or 6. And we didn't find it. So that means we're done. The factors of 73 are 1 and 73. Since 73 has exactly 2 distinct, that means different, factors, it is a prime number. So, when you are factoring, what you are doing is you are getting to the point where there's no more basic facts. So you basically, if the number is greater than a number times 12, a 1-digit number times 12, then yeah, you have to test it. But if this number is less than a 1-digit number times 12, you don't have to test it because you know your basic facts. So whenever you're trying to figure out, think of whatever that number is, 1 times 12. Is this number greater than the answer to 1 times 12? Well, then you have to test it. Or 2. 2 times 12, if it's less than the number you're finding factors for, then you have to test it. 3 times 12. If that answer is less than the number you're finding factors for, then you have to test it. Until the point where the number you're finding factors for is less than that number times 12, you have to test it. Does everybody understand that? Okay, let's look at example 3. So finger or pencil on example 3. Says, tell whether 1 is prime, composite, or neither. Find the factors of 1. What's the factor of 1? Colin? 1. Because only 1 times 1 equals 1. How many factors does 1 have, class? 1. So, is it prime, composite, or neither? Smith?
Neither.
Neither. Because a prime number needs how many factors, class? 2. A composite number needs how many factors, class?
4.
1 only has 1 factor. Does that fit prime numbers? Does that fit composite numbers? So, it is neither. Okay, While I get the guided practice ready, please get out a separate sheet of paper. You may get a small stack out. If you have that small stack still in your take-home folder, you can get that. Now, everybody look at number 1. The directions for this part say, tell whether each number is prime, composite, or neither. Now, your extra sheet of paper is because on that extra sheet of paper, you're going to find the factors. Okay? So, we need to find the factors of 5. So, on our separate sheet of paper, we're going to write number 1. And Carla, what is the first factor of 5?
The first factor of 5 is 1.
1. And what's the last factor of 5?
The last factor of 5.
5. So we're factor rainbowing. So give yourself space. Carla, next comes 2. First of all, is 5 even or odd?
It is odd.
So, is 2 a factor?
No.
No. What about 3? Can we multiply 3 by anything to get 5?
No.
So is 3 a factor?
No.
What about 4? Can we multiply 4 by anything?
No.
No. And now we're back at 5. We've met. So, how many factors does 5 have, Carla?
1.
I count 2. How many factors does it have?
2.
2. So is 5 prime, composite, or neither?
Prime.
Prime. Okay. Now go to your extra sheet of paper. And now we have 15. Smith, what's the first factor of 15?
1.
1. What's the last factor of 15?
15.
Is 15 even or odd?
Odd.
So is 2 a factor?
No.
What about 3?
Yes.
Yes. How do we know?
Because 3 times 5 equals 15.
Why did we not have to do division or anything for that?
Because it's a basic fact.
It's a basic fact. Good. What about 4?
No.
No, because all of our basic facts, what's 4 times 12?
48.
15 is less. That means there has to be a basic fact with 4, and there's not. What about 5?
Yes.
Yes, but do we have to keep going?
No.
No, because we met. We met our other side. So, Smith, how many factors does 15 have?
4.
4. So is it prime, composite, or neither?
Composite.
Composite. 4 is greater than 3, so that means it's composite. Okay, number 3. We have 21. Zadie, what's the first factor of 21?
1.
And what's the last factor?
21.
Is 21 odd or even? Zadie, look at the digit in the ones place.
It is odd.
It's odd because the digit in the ones place, can you divide it by 2?
No.
If you can't divide the digit in the ones place by 2, it is odd. So is 2 a factor? What about 3?
Yes.
Because 3 times what is 21?
3 times 7.
3 times 7. Now, let's think about 4. What's 4 times 12 first?
48.
48. It's bigger. So that means if 4 is a factor, there's going to be a basic fact with an answer of 21. Is there a basic fact for 4 with an answer of 21? You're just guessing. Think of your basic facts for 4. What's 4 times 5?
20.
21 is only 1 away. So is 4 a factor? No. What about 5? Do we have a 0 or 5 in the ones place? So 5 isn't a factor. What about 6? What's 6 times 12? Who can help her out? What's 6 times 12? Aaron.
72.
Loudly.
72. 72.
72 is greater. So that means if 6 is a factor, we have to have a basic fact. Do we have a basic fact for 6 that equals 21? No, because 6 times 3 is,
24.
nope. What's 6 times 3, Cullen?
18.
18. And 6 times 4 is,
24.
so this is in the middle. So 6 is not a factor. Now we're at 7. Do we have to keep going?
No.
Because we've met. So how many factors does 21 have?
4.
So is 21 prime, composite, or neither?
Impossible.
Okay, now let's try number 4. We have 31. Okay, I'm going to erase. So we're going to go to our extra sheet of paper. Victoria's not here. Lena, what's the first factor of 31?
1.
1. And what's the last factor?
31.
Is 31 even or odd?
Odd.
So is 2 a factor? What about 3? What's 3 times 12? Who can help her out? What's 3 times 12? Just shout it out.
36.
36. 36 is greater. So that means there has to be a basic fact with 3 if it's a factor. Is there a basic fact of 3 that equals 31?
No.
So is 3 a factor? Now, 4, we already know 3 times 12 is 36. That means 4 times 12 is going to be even bigger. So, since 4 times 12 is going to be 48, we know we have to have a basic fact with 4. Is there a basic fact with 4 that equals 31? What about 5?
No.
6? 7?
Yes.
7 times what would equal 31? What's 7 times 1?
7.
7 times 2?
14.
7 times 3? 7 times 4?
8.
28. 7 times 5?
35.
So, 7 times 4 is 28. 7 times 5 is 35. 31's in the middle. So is 7 a factor?
No.
What about 8? 9? 10? 11? 12. So, what are the factors of 31?
1. 30.
So is it prime, composite, or neither?
Prime.
Do you see how if you know your basic facts, it makes this really quick and pretty easy? Okay, let's try 26. Michaela, what's the first factor of 26?
1 and 26.
1. What's the last factor of 26?
26.
26. Now, is 26 even or odd?
Even.
Even. All even numbers have a factor of 2. Now, can we just move on to 3?
No.
No, we have to figure out what the factor pair is. 2 times 12 is what? Call it out if you know it.
8. 24.
24. 2 times 12 is 24. This is bigger, which means now we have to do some division. So to the side, we have to do some division. 26 divided by 2. Michaela, 2 goes into 2.
1 time.
1 times 2.
2.
2 minus 2.
0.
Bring down the 6. 2 goes into 6.
3 times.
3 times 2.
6.
6 minus 6.
0.
So 2 times what equals 26?
13.
13. Now, we need to figure out if 3 is a factor. Well, what's 3 times 12?
36.
36. That's bigger, right? Do we have any? So that means if 26 if 3 is a factor of 26, there has to be a basic fact with that answer. Do we have a basic fact for 3 that equals 26?
No.
Hmm?
No.
So is 3 a factor?
No.
What about 4?
No.
5?
No.
6?
No.
7?
No.
8?
No.
9?
No.
9 times what would equal 26?
Oh,
No, because 9 times 1 is
no.
9 times 2,
18,
9 times 3,
27.
27 is bigger. So we don't have. What about 10? 11? 12? And now we're done with the basic facts, and also we've met. So how many factors does 26 have?
2.
How many factors? Not
Oh.
factor pairs.
Oh, 4.
4. So is 26 prime, composite, or neither?
Composite.
I'm going to give you a hint right now. All even numbers are composite. Because all even numbers have, of course, 1 and the number itself, but also 2 and some other number. So, if you find an even number, do you even have to factor? Nope. Because all even numbers are composite because they all have 2 as a factor. If you come across the number 28, is it prime, composite, or neither? Zari,
Composite.
how do you know? We didn't even factor it. But how do you know that?
Because the whole number is even.
Because 28 is even. What if you come across the number 132? Is it prime, composite, or neither? Mason, composite, how do you know that's such a big number we didn't factor?
Because the number is even.
Because 120 or whatever, 132 is even. Okay, one more, number 6. And then I'll give you about 15 minutes now, and you'll have time this afternoon to do more. Okay, number 6. We have 61. You are factoring every single number except what numbers do you not have to factor because you automatically know what they are. There are 3 numbers that you can go ahead, you do not have to factor. Smith,
Composite numbers.
but how do you know if it's composite, if it's what type of numbers? It's not prime or composite because this one was composite, but we had to factor it. There are 3 types of numbers. There's 2 numbers specifically and 1 type of a number that you don't have to factor. Zadie?
Even number.
Even numbers. And then there are 2 numbers that you don't have to factor because you already know. What are those 2 numbers? Michaela? 1 and
Itself.
not 1 in itself. Itself is not a number. So, even numbers. 1 and Cullen?
2.
Not 2. Zari?
0.
0. Wait, I have to tell you one exception to the rule about even numbers. There is 1 even number that is not composite. What is it? There's 1 even number that only has 2 factors. Only 1. What is it? Michaela?
1.
1 is not even. Can you divide 1 by 2?
No.
So it's not even. There's 1 even number that is prime. Smith?
16.
Michaela?
2.
Correct. 2 is the only even number that is prime. Because can you multiply 2 by anything other than 1 to get 2? Smith, you have a confused face. Why do you have a confused face? Are you thinking, but 2 times 2 is 4? Is that what you're thinking right now?
No.
Were you thinking that for a split second?
No.
Okay. Why do you have a confused face?
I was just confused about 16, but now I get it.
Yeah, because there's 1, 2, 3, 4, 5 factors of 16. A prime number only has 2. 2 only has a factor of 1 and 2. So 2 is the only even number that is prime. Every single other even number is composite. Okay, sorry, one last one. Let's look at 61. Aaron, what's the first factor of 61?
1.
What's the last factor?
61.
Is 61 even or odd? So 2 is not a factor, right? What about 3? What's 3 times 12? Bless you. So it's bigger, right? So we have to test. Bless you. Oops. Everybody should be testing. Don't just watch me test. That's what you're doing when you zone out and you're not paying attention. The more you do it, the more practice it is. Aaron, 3 goes into 6. 2 times 3. 6 minus 6. Bring down the 1. 3 goes into 1. 0 times 3. 1 minus 0. Is 3 a factor? Nope. What about 4? 4 times 12 is 48. That's 61's bigger, right? So let's test. Aaron, 4 goes into 6. 1 times 4. 6 minus 4. Bring down the 1. 4 goes into 21. Five times 4. 21 minus 20. 6 a factor. What about 7? 7 times 12 is 84. 61 is less. That means there has to, if 7 is a factor, there has to be a basic fact that equals 61. Is there a 7 basic fact that equals 61? Now any other number higher than 7 is going to have a basic fact. We already know that. 8, 9, 10, 11, 12. Do we have any more basic facts? So what are the factors of 61? So is 61 prime, composite, or neither? Prime. Hey, this is where knowing your basic facts really comes in handy. This is, no. You may use your multiplication facts chart today. If you know them, do not use it because it will make you forget because you'll get used to it. So go ahead. I'll give you 15 minutes. So we'll start religion about 5 minutes late. I will give you 15 minutes now. Actually, I'll give you 20, not religion, reading. Well, I'll give you 20 minutes. So we'll start reading about 10 minutes late, but that's okay because we have a grammar quiz. We have only religion and then a grammar quiz and then the rest of the afternoon, like a normal Friday, because we have no spelling test. So go ahead. I'm going to give you 20 minutes now. It is not your only 20 minutes. You will have time later today if we use our time wisely the rest of the day. Unlike yesterday, where grammar took so much longer than it should have because nobody was paying attention when other people were answering. Not no one, but most people. So go ahead. Unless the number is even, 1, or 0, I need to see factoring. Does everybody understand? If you know your basic facts or you use your basic facts chart, you'll be able to tell right away. If the number is greater than the number you're trying to figure out if it's a factor times 12, like when we were doing 26, we needed to think, well, we know 2 is a factor. 2 times 12 is 24. 26 is greater, then you have to do the division. If the number is greater than the factor you're testing times 12, you will have to do division. Does everybody understand? I'll say it one more time. If the number you're finding factors for is greater than the factor you're testing times 12, you must do division. If the number you're finding factors for is less than the factor you're testing times 12, you don't have to do division because there will either be a basic fact that equals that or there won't, and it won't be a factor. Okay, go ahead. You'll have until 9:45. And look at number 14 on your homework. Pause and look at number 14 on your homework. It says, Winnie has 7 soccer trophies she wants to display in, number 13. Number 13 and number 14, really. Well, whatever. Let's just finish number 14 first. Winnie has soccer trophies she wants to display in an array. How many different arrays are possible? That means the answer should be blank arrays. Like in number 1, we found 3 arrays. But there were also the opposites. So, I'm sorry, there were only 3 arrays we can make. We could only make a 1 by 18, a 2 by 9, or a 3 by 6. So there were 3 arrays. So if it was a question like that, you'd have to say 3 arrays, and then the explain is where you list them. 1 by 18, 2 by 9, 3 by 6. Okay? So there's 2 parts to that answer for number 14. How many arrays? She can make this many arrays. Explaining is, well, she can do 1 by 18, 2 by 9, 3 by 6, but for this number. Number 13 is the same. Number 13 is the same. Colby has 16 jars of spices. He wants to arrange them in arrays. What arrays could he use to arrange them? The only thing you don't have to say is blank arrays. You would just say he can do 1 by 18, 2 by 9, 3 by 6. Okay? So do not lose points because you just put like one little thing down real quick. For number 14, you have to list the arrays. Like in number 1, 1 times 18 was an array, 2 times 9 was an array, 3 times 6 was an array. On number 14, you have to list those arrays plus count how many there are. There are 3 arrays. 1 by 18, which is the same as 1 times 18, sorry. 2 times 9, 3 times 6. There's 1, 2, 3. Okay? Make sure that you don't lose points just because you're trying to get through it. Okay, go ahead. Yes. Yes, I will come around and staple in just a second. No, you can keep going on the same one. Oh, but a different sheet of paper for your homework. Yes. You may use the same sheet of paper that we've been using for the rest of the independent practice, but you need to use a different sheet of paper for your homework.